right, good afternoon, front runners. My name is Alec Barrett, and this is Build Your Own Devtools. So let's start with an example. Suppose I'm working on a table with sortable columns, and if I click on a column header, I want to see the sort order added to the URL so that users can share that URL with the state persisted. Now, how would I check if this is working? Well, first, I'll apply the sort in the UI, and then I'll go to the URL bar and I'll look for the sort parameter, and I'll mouse through or drag and click, and if I want to edit it and see that it works in the other direction, I'll edit the URL bar and then look for that effect in the UI. But if I'm editing the URL, I have to be careful not to modify any of the other parameters. If the URL is longer than 150 characters, I'm not going to see it right away. I'm going to need to click and drag or arrow back and forth. And so you're probably seeing that this isn't the most ergonomic process. Modern application URLs tend to be long. The URL bar is a one-dimensional interface for information that's actually nested and hierarchical. And there's a lot of encoding of characters that are not designed for human consumption. So we'll return to this example to see how Devtools could help. Taking a step back, a little bit about me and where I work. I have been at Datadog for coming up on 4 years. I've been a manager of an engineering team there for about 1.5. I'm originally from New York City, but now based here in the District of Columbia. I'm passionate about data visualization, which has been the focus of some of my previous jobs. And outside of work, I'm usually biking or doing crosswords, not at the same time. And Datadog, where I work, is an observability platform for cloud infrastructure and applications. We've got over 5,000 employees right now. But within our engineering org, we've got a pretty tight-knit front-end community. Offices are in New York, Paris, Boston, San Francisco, and other places. And we like to say that we eat our own dog food, which, yes, it's a good dog pun, but it's also important because it means that we're the first users of our product. And our customers are also engineers. So if we notice pain points in the product, that helps us anticipate theirs, and it makes our products better. Our products tend to be geared toward back-end engineers and SREs, but we've got a growing suite of front-end monitoring tools. And this dynamic also means that our front-end teams can build our own tools for us to use internally. So here's a roadmap for the rest of this talk. I'll talk about some facets of developer experience that I think can be improved by Devtools and investing in them. I'll give a definition of developer tools and some qualities that I think make them good. I'll demo some tools that we've built in-house at Datadog and also some tools that others have built that I enjoy using. And I'll talk about some successes that we've had and some problems that we haven't solved yet. So we can think about opportunities for improving developer experience along 2 lines, technical and organizational or cultural. On the technical side, let's think about what front-end developers do all day. First, we build features. And when we're starting to build a new feature, we might look around for some prior art to fork or emulate. We might use a components library, and at Datadog we have an internal one called Druids. You can see a screenshot from the public documentation of Druids here. We probably also want to write and run some unit tests to make sure that our business logic is sound, and we'll tweak those and add more test cases as we go. Second, we might want to improve the user experience of existing pages. So we might want to measure page performance, collect telemetry to understand how users interact with our product, which endpoints are taking the longest to fetch, are we doing expensive computations more than is necessary, do users on different browsers get the same or different experiences? And third, we inevitably have to fix some bugs. So we'll start by triaging to understand how severe it is, what the impact is. We'll try to reproduce them locally and diagnose the source. And once we have a fix ready, we'll probably want to add some more unit tests to prevent regression. On the organizational and cultural side, there are some additional dynamics that could make developer experience better or worse. First, people arrive. And when they onboard, new engineers receive a ton of information. And that might include developer tools that are at their disposal. But it won't mean much to them in their first week on the job. And maybe some of that information isn't even written down anywhere. It just lives in the head of employees who have been around for a long time. So we want engineers to have access to information when they're ready to use it. And that probably means introducing Devtools more than once and over time. Second, people leave the company. And we want to create positive redundancy so that institutional memory doesn't walk out the door when somebody leaves. We also don't want people reinventing the wheel because nobody remembers that somebody built a wheel 3 years ago that's still in perfectly good condition. Third, there are silos, and different teams could come up with very similar solutions to the same problem. We want to try to eliminate negative redundancy caused by those kinds of duplicated efforts and encourage reusing existing tools whenever possible. And finally, we can think about culture as the water that we swim in, and tools can change habits that we might not even have realized that we had. So we want to introduce better ways of working that we might not have considered. A good example of this is the way that Git tools like Graphite make stacked PRs the default way of working. But without those tools, stacking PRs is a really inconvenient and maybe even inconceivable way of working. So I'll talk about my working definition of Devtools, some qualities that make them good, and trade-offs between using an off-the-shelf tool and doing it yourself. I think of a Devtool as a tool that improves human-computer communication in order to make a software developer's task faster or more ergonomic. And I want to drill down on a couple of those terms. So human-computer, because computers are basically opaque interfaces to us. And a lot of the times when coding is difficult or unsatisfying, it's coming down to communication issues. Either the computer doesn't understand what I'm telling it, or I don't understand what the computer is trying to tell me. And tools are about bridging that human-computer divide in order to extend and enhance the things that we, the humans, are naturally good at. A task implies something that we're doing more than once, whether that's once or twice a day or many times an hour. So a one-off activity probably doesn't warrant its own tool, but if you notice yourself encountering the same problem over and over, that's a good opportunity to intervene with a dev tool. And finally, ergonomic, because tools alleviate our metaphorical and sometimes psychological pain. Waiting for your type checker to pass or your unit test suite to run is boring. And context switching between dozens of tabs or open windows breaks your concentration. Trying to debug minified.js is like finding a needle in a haystack. And there are a lot of other potentially confusing or frustrating activities like this in a developer's workflows. So what makes a dev tool good? A few guidelines I like to keep in mind are that first, it's tailored to your context, which means it's not too general. So it works with your stack, your way of working, your usage patterns, and it addresses real pain points, not hypothetical ones. Second, it's reusable, which means it's not too specific. And you use it often enough that you remember it's there when you need it. Ideally, it's also relevant to more than one person on your team or at your company so that you get benefit from the scale of it. And whoever's using it, the cost to acquire it is justified by the usage you get out of it. And we can think about that along two dimensions, cost versus usage. So a good dev tool should live in the upper left corner. It's not too expensive and it gets lots of use. So we're looking for something that's akin to a good kitchen implement and not a disposable contraption. And third, a good dev tool should abide by the Hippocratic Oath and do no harm. It shouldn't add net overhead. It shouldn't slow down your app by more than it saves you in performance. And it shouldn't interfere with your production users. So the title of this talk is Build Your Own Dev Tools, but I want to acknowledge that there are trade-offs in doing that. Getting an external tool off the shelf, whether it's free or paid, has some advantages. For example, somebody else makes the feature updates. There could be a user community, a support channel, documentation. There's a lower risk of drift if it's somebody else's job to keep the tool up to date with new libraries and releases. On the other hand, if you do it yourself, it's easier to add and modify features. You get the features you need and only those features. And it's more likely to address your problems and not someone else's. That's the real but not hypothetical pain points I was just talking about. You also get the tool at cost, and you're probably paying in time rather than money. And it's tailored to your stack. So if you use Angular instead of React, if you use Yarn instead of NPM, you know that the tool is going to be compatible with those systems. And if you have other tools or a tooling platform, you can integrate it as a feature instead of building a standalone system every time. Finally, and this is the one I like the most, engineering is about solving problems, as we've been talking about here today. And most of the time, we're solving problems for somebody else, a customer, a user, a client. But there's something very satisfying about taking those same skills and applying them to your own developer experience by building Devtools. Another way to think about usage and cost is considering the time you'll save. And XKCD crunched the numbers on how much time you would need to save to actually justify the investment in making a task more efficient. Now, the work I do tends to fall around here. A dev tool might save me 5 seconds or 30 seconds on something I'm doing a few times a day. And that means I could justify spending around 12 hours of focused coding. So that might mean a 2-day hackathon. It might be a week of regular work when I'm also working on other things. There in that bottom corner, you'll notice things that you could save an hour or more on. I'm super curious about what might fall in that category, and if you have something like that, I'd love to know more about it. So returning to that example I shared at the beginning of the talk, I want to test that behavior. When I click on a column header to change the sort order, the URL is updated. And as I mentioned before, the URL is not a good interface for us. If the URL is long, you can't see the whole thing. There are encoding characters that are there for computers to see, but we have to look for the words in a language that we understand. And if your application encodes state in URL, this is a pretty common problem. This is not hypothetical, it's a real problem that I was encountering working on our page. So how could a dev tool help me here? The solution I came up with, I call the URL Pretty Printer, and I added it to our in-house Chrome extension. It takes the URL string and structures it into a base route and a hierarchy of parameters. I can edit parameters individually, and I can also step back in time to see the diff for every application of changes to the URL. Now, when I was building this solution, as I mentioned, I already had a Chrome extension that I could add it to, thanks to my colleague Mael and other front-end engineers. So I could focus on adding just that one feature without having to bootstrap a whole Chrome extension from scratch. And other engineers have also added their own features to our Chrome extension, which is making it an increasingly valuable platform for our dev tools. I also want to humble brag for a second. I wasn't the only person who had this pain point, and I received this feedback from a colleague about the feature that I shipped. This next tool that I want to share lives in a storybook instance where we keep demos of components and other UIs. So at Datadog, we have lots of different data from different families of units. We have time, memory, percents, dollars. And to standardize how we display that data, we have a utility function that takes in a number and some config parameters, like how many digits to show or whether to put a comma separator between the thousands. And the problem is when you're looking at source code of that function, it's hard to remember what all the configuration options are and what effect they're going to have on the number. So the solution that my colleagues Cameron and Becca built is this UI for the number formatter. You enter the number, you select some config options, and you immediately see the output on the left. This gives you instant feedback without having to spin up the full front-end application. This next dev tool is a little bit different in that it's actually available to users of our product, not just our developers. And that's because it's attached to a feature where users can write a JSON spec in Vega Lite, which is a visualization grammar. So to give a little context, most of our dashboards are like this. We have a widget where you can write a custom query, and then you can select from one of a few pre-baked visualization types. But we also have a beta feature called the wildcard widget, which looks like this. In the wildcard widget, you can also customize the visualization using that Vega-Lite spec I mentioned. And the problem that the Devtools seeks to solve is that writing the Vega-Lite spec requires knowing the format of the data that's coming back. So things like the names of the fields and the data types. And once again, this is a real pain point that I had when I was testing out this beta feature. So the solution I came up with is to build a preview of that data. We can see a table with the data coming back, as well as some metadata, like the data types of the columns, as well as the internal state that the Vega-Lite renderer is seeing. So this takes the guesswork out of writing the Vega-Lite spec because we can see exactly what the renderer is seeing from the query. And I want to emphasize this is not a super elaborate UI, but sometimes that's all it takes to bridge that human-computer gap. Earlier, I talked about a common workflow for us front-end engineers when we're starting to build a new feature, which is to look for similar existing features that we might want to emulate. So especially if we're using a component library, you might want to see what component library components are already in use. And one problem we've had is how do we know the name of the component we're seeing or how to import it into our file? And a solution that our design ops team came up with is called a loop. A loop is named after that monocle that jewelers wear to see things that aren't visible to the naked eye. And the way it works is when you turn it on, all of the components that come from the component library are highlighted in pink. And when you hover over them, you get a link to the documentation as well as the name of the component so that you can use it yourself. And this helps me find what I'm looking for faster, and it takes the guesswork out of having to browse through the entire component library catalog. Another workflow we've talked about is debugging. So for example, you know there's a problem in the UI, you see the component that's broken, but you don't know where the code for it lives. And for me, the way I would previously have solved that problem is by opening Chrome Devtools, looking at the Elements tab, searching for some sort of identifiable piece of data like a class name, and then if it's a unique class name and I'm lucky, then I can search for it in my code base and I'll find the file. But if it's a common class name, I'll find a dozen or more files, and then I have to go back and try to find a more unique identifier. So there are a couple of problems here, which is that the Elements tab isn't particularly friendly for humans, and second, that it takes time to do that switch between the UI, the Elements tab, and my editor. And the solution is another kind of loop, which I built. And I added this again to our Chrome extension when we're running the app in local. So when you apply this loop, you see in pink any component that is a top-level export of a JSX or TSX file. So it's a React component. And when I click on that, I get taken immediately to the component source code in VS Code. So this increases the chances that I find what I'm looking for on my first try, and again, speeds up the process of finding and solving a bug. So the last internal example I want to talk about pertains to writing and running unit tests. So here I've got a unit test file on the left. I've got a bunch of different specs for it. And previously, the way I would run this is I would go to a terminal window and I would type out yarn unit test and then the file. And if I want to run just one spec, I'll put in some part of the name of that spec. And this isn't terrible. This is, a manageable workflow, but it's the kind of thing that if you're doing it dozens or hundreds of times a day, starts to consume a lot of time. So the solution I built is to create a custom VS Code extension that adds a code lens to our unit test files. So I'll install the extension here. And then I can see these code lenses pop up. On the left, run the test file, or over each spec, just run that individual block. And that means I can launch a test with one click, without typing anything, and most importantly, without leaving the context of the file that I'm editing. So I can write and run unit tests faster, speeding up my feedback loop, and ultimately making the code more reliable. I also want to talk about two external dev tools that I like and which save me and my colleagues a lot of time. If you're writing a Vegalite spec, the online Vegalite editor has a sandbox like this where you can get instant feedback on code changes. You change a line, and you immediately see your graph update. And we also use React Developer Tools, which has its own Chrome extension. This one works similar to the Elements tab, but it shows me a view of what the React component is seeing. So if I select a component and then click on it in the components hierarchy, I can see props and state that are sort of the React eye view of that component. So you may have noticed these Devtools can live in a lot of different places. There was a standalone sandbox like Storybook. There were in-app tools like the loops. There's a browser extension like the URL Pretty Printer. And there's an editor extension like the Test Runner Code Lens. And where you put a tool depends a lot on who's using it, what part of your workflow it's involved in, as well as technical or security constraints like what data it should and shouldn't have access to. So how do we know if our investment in front-end Devtools is providing value? Here are a few successes we've seen. First, standalone tools are becoming extensible platforms. So our Chrome extension and our VS Code extension have become hosts to multiple features, and it's easy for engineers to add their own. This lowers the barrier to entry for new developers, and it also reduces the time commitment for anyone who wants to contribute a feature. Second, we know people are using the tools. And I shared that example of one person giving me feedback that they used something I built, which is great. But it's really gratifying to look at a dashboard where I can see that dozens of my colleagues are making thousands of invocations of that VS Code extension. And third, we have an inventory now of all of our internal existing Devtools. That increases institutional memory about what tools already exist, and it makes it easier for new engineers getting onboarded. And when new engineers want to add their own tools, the inventory encourages them to extend existing projects instead of starting from scratch. And it also tells you that if you create a tool, there's a good chance that other people will want to create and collaborate on it as well. And in a sense, tools are a kind of self-documentation also of the processes that we use that those tools support. So for many people, I think using a tool is better than reading documentation to learn how we work at our company. And in that sense, an inventory of tools also tells a story about how we work. But there are still a few problems that we haven't solved yet with our growing use of Devtools. First, as we have more people relying on and contributing to those tools, it becomes important to have traffic controllers to prioritize bug fixes, triage feature requests, and coordinate new releases. Second, DevTool development is still pretty ad hoc, and we don't yet have a practice of regularly reflecting on our developer pain points. If we did, that would allow us to prioritize fixing those and addressing those more systematically. Third, our tools still need better metrics for success, like time saved for developers, increased test coverage, reduced time to resolution for bugs, etc. And this, with out-of-the-box telemetry, would let us make data-driven decisions about where to focus our future investments. And finally, it's hard to say if we should dedicate time and resources to building Devtools that take longer than a hackathon or an R&D sprint. Personally, I would love to spend 3 weeks building a better interface for Chrome performance profiles, for example. But product teams and platform teams have a lot of other obligations, and that's a little bit hard to justify sometimes. So we need to break these problems down into parts so that we can iterate quickly and prove value. But despite those problems, I'm confident that we're going to keep making progress because we're making some cultural changes as well. For example, my colleague Cameron and I ran a workshop at our annual summit for front-end engineers. We gave an introduction to some existing tools, and then we split our participants into groups so they could think about the pain points that affect their developer experience and ideate some possible solutions. And they came up with 14 ideas, which then they passed around on paper and over Slack. We're also giving regular demos at our monthly front-end fishbowl meetings, where we can evangelize new features and recruit beta testers. We have a dedicated Slack channel for front-end Devtools where people can leave feature requests, ask for help, and suggest new ideas for tools. And we put out a guide around our twice-a-year company hackathons, sharing tips on how to effectively contribute to the front-end Devtools ecosystem. We share the inventory that we created, and we update it after the hackathon to reflect new contributions. And twice a year may not seem like a lot for making progress on these tools, but if we are judicious about where to focus our efforts, and more importantly, if a lot of people are using the tools that we create for a long time, these benefits are going to accumulate. So in conclusion, I want to encourage you to build your own Devtools, to shift your focus toward hard problems and away from needlessly slow or frustrating tasks, to reduce pain points in your developer experience, and to make building features and fixing bugs more ergonomic and satisfying, and to engage in more play and creativity, both while you're building the tools and with the time and bandwidth that you will gain from using them.